Thank you very much, Ivar, for a kind introduction, and thank you for the invitation to talk here at this seminar. I just want to make a comment on this that Jane put forward. There's a broken link between the science and the farmers. I think also you need to have a connection between the scientists and the industry, just in order to make sure what is suitable, what is doable in an industrial way. It's no mean if you come to a farmer and give a crop that is no industry want to take care of. So you need to have that connection too. All right. My name is, as Eva said, Hans Grundberg. I'm a development engineer at the Domsjö Fabriker in Örnsköldsvik, 600 kilometers north from here. We call ourselves a unique biorefinery, and this is a forest-based biorefinery. We are, since 3.5 years, a member of the Aditya Birla Group, which is a huge Indian conglomerate. Its revenues is around $45 billion, and they are growing actively. They want to be even bigger than that. Most of the revenues come from outside India, but they have operations in all parts of the world. But it is a family-owned company, the Birla Family. Our slogan is that we use trees, we would use wood, and we want to make more of that. So on this picture, all these products, they have components that comes from or can come from Domsjö. And I will say that we don't do any paper grade pulp. Everything that we make goes outside the traditional paper and pulp industry. I will come back a little bit to what kind of components we have in these different products. As Ivar already, or I think it was Melinda who stated this, that resources are limited. We have a lack of food. We are specifically interested in cotton because this is an area where our product is used. Of course, oil, and I agree with I think it was Ivar, that the water issue is something that is very critical. Coming back to the peak water issue, this is the Lake Aral that was once the third largest sweet water reservoir in the world. And you see the contours of the lake, how it was previously. And I have seen more recent pictures that it's even worse now. And the reason for this is irrigation of cotton fields, mainly in Uzbekistan. We are focused, our main product in the Domsjö mill is dissolving grade cellulose, and it is used in textile fibers through the viscose process. And we know that there is a lot of need for new textile materials in the world in the future. If you look at the fiber consumption, in 1960 we were 3 billion people on the earth, and we used approximately, on average, 5 kilos of textile per person and year. In 2012, we were 7 billion, and we used 12 kilos of textiles per person and year. And in 2050, the prediction is that we will be 9 billion, and we will use 35 kilos of textile a person per year. And the reason is that the developing countries are getting more and more money, and they want to have the same standard as we have in the Western world. We have a consumption of, I think it's around 35, 36 kilos on average per year of textiles. And of course, this is not only textiles that we wear as clothes. I mean, you have the seats that you're sitting on. There's a lot of curtains. You have a lot of industrial textiles that is also within this scope. If we look at the world consumption today, there are approximately 86 million tons of textile fibers per year that is used. Most of it is synthetic polyesters, and they go mainly for industrial technical fibers. Clothes are usually for cotton. You have this comfort fibers, I mean, fibers in polyester and synthetic fibers. They are not very suitable to wear. You get, they don't breathe too much. So you want to have cotton as a wearing textile. And then you have viscose, which is dissolving grade or cellulose that has been regenerated. Cotton is cellulose, basically. It's a pure cellulose. However, if you look in the future, there will be a gap. We'll see that you have a production of or a demand of oil and cotton availability that is basically the same. You will have approximately the same amount of cotton, because you can't grow too much more. There's a limitation of cotton growing, because you have a competition with food, of course, and then you have, since the cotton is using a lot of water, there's a restriction. But the demand is much higher, so you'll have what we call a fiber gap. We need to replace this, or we need to find a source for this demand of textile fibers. And then the question comes, how should we dress in the future? And if we look at the cotton, there's a big problem with that, because you need to grow it in quite dry areas, because if it rains on the cotton buds, they start to mold, and then you can't use them. But they need a lot of water, so you need to irrigate it. So they use, as you saw on Lake Aral, you need a lot of water. And furthermore, approximately 2% of the totally used agriculture areas is used for cotton. But they are using more than 11% of the total chemicals used in agriculture, and more than 25% of all the pesticides. Because these cotton buds, they are very good food for the insects, very easily available. So of course they want to utilize that. So this is a problem, and we think that if you have cellulose coming from the forest instead, and you can regenerate that into fibers, then you have a part of the solution, because the forest, they require no irrigation, no pesticides, and basically no chemicals. Of course, you can have fertilization. Fertilization of forests are increasing, as you do in agriculture. You are increasing the growth, of course. Here in Sweden, we have a kind of a problem if you want to compete with for example, Southeast Asia or South America or South Africa also for that case. You have a very large cellulose pulp mill in South Africa, Sub-Saharan, and they are using eucalyptus, and you have a rotation time of approximately 7 years. So you grow, the growth rate is around, I think it's 50 to 60 cubic meters per hectare a year, and in Sweden, northern part of Sweden, you have approximately 2 to 3. So it's a little bit difference. We need to grow our trees in up to 100 years before we can harvest them. But if you add fertilizers, you can cut that down by half. You can increase the growth to up to, or you can even more, I would say. There are some test areas where you can grow Swedish spruce at approximately 30 cubic meters per hectare a year in the northern part of Sweden. And the forest is not competing with food production. Within the Birla Group, we're adding value across the value chain. So we have from plantations, we are making cellulose, dissolving grade cellulose. We dissolve the cellulose and regenerate it into fiber, make yarn, go fabric, and then we can make fashion. And we have that whole chain within the Birla Group. So we have sort of control. We can vary different parameters, and we can try and we can make new tests. If we look at the wood components, this is what we are dealing with on a daily basis. You have three main components. You have the cellulose, which is the straight line of glucose units. You have this hemicellulose, where you have more branched and more varied composition of the sugars. And then you have the lignin, which is the glue in the wood that holds these fibers together. And then you have a small part of extractives, which are, you can say it's like oils. And what we do at Domsjö, if we compare to a traditional pulp and paper industry, is that in the pulp and paper industry, you want to have a tree fiber that is strong, durable. You want to make a good paper or a packaging material. So you want to have it as untouched as possible. So you take the hemicellulose and cellulose and take the fiber out. The lignin is dissolved, and part of the sugar part is also dissolved. And then you take that into your recovery boiler, regain the cooking chemicals, and you also get energy out of it. In our case, or what we see, our customers, they are interested in the molecules. We are going down one step in the hierarchy. So our customers are interested in the cellulose molecule, the behavior of that. They're also interested in the monomers of the hemicellulose, because in our process, we are breaking down the hemicelluloses into monomeric sugars that we can ferment into bioethanol. So this is basically second generation bioethanol. And a couple of years ago, I went to a couple of conferences, and everyone was asking, well, when does the second generation ethanol come? It came 100 years ago, approximately. The first cellulosic ethanol plant, sulfite-based ethanol plant, started in 1909. So it has been around for quite a long time. The sugar stream here can be utilized for other things than ethanol, of course. We have now a project where we are looking at making single-cell protein from it. So you can grow single-cell protein on our stream. Where you can also, I mean, this is, today we are looking at these single-cell proteins as fish feed. But of course, I mean, it's the same microorganism that they're using for corn. So basically, we can grow food, not only feed, on our side streams. And just a comment on your saying waste. We don't use the word waste. Waste is banned in Domsjö. We see that if you have a pile of something, that is a stream of not utilized feedstock. So waste, we don't want to talk about that. We want to utilize the whole thing. The lignin that is burnt just to make energy in the traditional pulp mill, we're using as an additive in concrete to reduce the amount of water. And that gives a lot of savings First, of course, in places where you don't have too much fresh water, you save water. But you also make the concrete stronger, which means that you can use less cement, and cement is very energy demanding. And here is also the quality or the properties of the lignin that is interesting. And then, of course, we have part of this is used as bioenergy, because we need energy in the process, of course. We started in 1903, and during the years, you can see on the y-axis how the production has increased. And I would like to comment on this. You see here, ethanol wood chemistry. During the Second World War, fuel was very scarce in Sweden, or we have a lot of problems getting oil into it. So at that time in Örnsköldsvik, we started ethanol chemistry. So we had a big palette of, I think it was 70 different compounds that was made from ethanol. And this was actually an A-class equipment that was guarded all year around with just to make sure that it was not destroyed, or that there were no attacks on that site, because that was of the nation's interest, that equipment that time. And you can see also that we have made specialty cellulose, this green yellowish area, already since the 30s. So already then we were a biorefinery. I think we were more biorefinery then than we are now, because then we utilized the ethanol in a more sophisticated way. But then during the 80s, it was 70s, the demand for the specialty cellulose went down, mostly because of the entrance of the synthetic fibers, of course. So the demand for viscose was lowered. We had a biological treatment plant that is today one of the biggest producers of biogas in Sweden. We closed the bleach plant, so we made it totally chlorine free. So it's, what I know, one of the only mills in the world that has a totally closed bleach plant. No effluent from the bleach plant is going out into the recipient, and it's also totally chlorine free. Up until 2000, this was belonging to the Modo company. But at the end of the 20th century, this company was split it up, and no one wanted to take care of Domsjö. They wanted to shut it down. And then it was bought by some investors, and they were focusing on this biorefinery thinking. So we moved toward dissolving grade cellulose, and from 2007, we made our last paper grade pulp. So after that, we have only dissolving grade cellulose. Then we were acquired by Birla 2011, and we also started the lignin business in around 2005. And in the beginning, we started to sell liquid lignin, but now we have 2 dryers that can produce dried lignin that we ship all around the world. What do we do then with the product, or what do our customers do with the cellulose? Well, approximately 70% goes for fashion and textile. So if you go out and see viscose as a brand, or Tencel, then you have regenerated cellulose, and it might be Domsjö cellulose that you find in there. You can also use this in hygiene articles. Dishcloths, for example, if you buy a Vetex dishcloth, you definitely buy Domsjö, because we are the only supplier of cellulose for the Vetex dishcloth. You can use cellulose also in food as a thickening agent. You have microcrystalline cellulose, or you can also have carboxymethyl cellulose that is used as a thickening agent both in food and in paint. If you have a pill, that is basically cellulose. The main part of that is cellulose, but then you have a little part that is the active ingredient, but the most part is cellulose actually. And then actually, if you buy a sausage, you need to have a casing around that sausage. Or if you have a sausage, a casing-free, a skin-free sausage, you need to have a casing when you make it. And that is also made by cellulose, actually. And we are quite big on that market. So I think that if every 10th sausage you eat, you have had a sausage with Domsjö cellulose.
In Sweden?
No, all around the world. Globally, yes. Or maybe 1/15 or something like that. But we are quite big in that. Very important, yes, sure. The Domsjö Lignin is mainly used as an additive in concrete. As I said, it makes the concrete flow better, so it go out into the molds in a better way. And we can also use it as a binder in mineral and food industries. And this have a big impact on the environmental issues. Because you can calculate that if you use 1 kilo of lignin, then you reduce the CO2 emissions by 20 kilos. Because of the fact that I said previously that you can reduce the amount of cement in the concrete but still have the same strength. And since cement is very energy demanding and you need a very small amount of lignin in the concrete, you get those numbers. And since we make approximately 120,000 tons, so we have the capacity of 120,000 tons of lignin, that means that we are reducing more than 2 million tons of carbon dioxide. And that's quite a significant number. I think the total Swedish emission is around 85 million tons of carbon dioxide. So this is you're on the percentage level of the Swedish emissions. And then we have the bioethanol, and we are not selling it to different customers. We sell it to Sekab, who is the ethanol company within the Domsjö area, and then they further purify it and refine it and sell it to different customers. But you can find it mostly in windshields, wipers, and you also have it in heat transfer media. Those are the main usages. But you can also use it as a fuel, of course. Within the Birla Group, we are focused on the textile chain, of course, and we have the R&D and I stands for innovation. We have the capabilities for the whole chain. In the Domsjö area, we have the former Modo Research and Development Company, which is now called More Research, where we can make cooking and digestion. We can also bleaching, and we can also make viscose and spinning fibers. And then within the Birla Group, of course, you have the viscose production and we have the fiber production, but they can also make textiles and they can make clothes, actually, just to test to see the properties of the products. And this is a very important thing. Just as I mentioned, we need to find a way to get the market to be interested. We can't come up with a product that the market is not interested in. And finally, the environmental situation. In the beginning, we were as bad as all other pulp mills. We just let out our spent liquors into the river. So the river and the bay outside Örnsköldsvik was totally dead, basically. But now, because of the biotreatment plant and also that we have closed the bleach plant, we have got a very low emission ratio to the environment, or to the effluent, and we have a lot of measurements and things like that to look at the oxygen levels in the sea and so on. But the best evidence is that you can actually go down. You see the mill. You can go down and catch trout in the river, and trout is very picky on water quality. So this is the best evidence that we have done something good. And we have also the values from the Birla Group, that we have integrity, commitment, passion, seamlessness, and speed. But sometimes the speed can be a little bit problematic because you're running too fast. So there's a little bit of culture collisions there. If we look at how can we learn towards Africa, what can we learn from that? Is that this is an example of a biorefinery thinking. This could be applied in Africa also. You have a big mill in South Africa. It could be utilized on other raw materials than wood, of course. The process are there, but the thing is, you need to utilize the whole feedstock. You want to make as good as possible products out of the whole feedstock. If we hadn't have all these three legs to stand on, if we only had the cellulose, we had a big problem, because now the cellulose price is low, but the lignin price is high. So we survive due to the lignin, actually. So it's very important to have this possibility, not only to focus on one thing, but to find use of the whole feedstock. That is the message that we have learned. Thank you.